Welcome. In this tutorial, we will be covering data binding entities within Tellus Studio. Prior to starting this tutorial, please ensure that you have completed the Building an Airspeed Gauge tutorial and exported the gauge as a prefab. If you haven't, click on the link in the video's description to go to that tutorial. To begin, ensure that you have the model browser open. First, we need an entity to work with. Drag a UAS entity from the model browser into your view. Then, attach the 3D camera to the entity you just placed to make it easier to view. You'll notice that the model is flying around. This is because the entity has a flight controller and flight data preloaded on it. In the TimeSync view, click the Show Paths checkbox. This will show the flight path of your UAS entity. You can click and drag any of the green boxes along the path to modify it. Notice that while modifying the path, the camera is still moving. This is because the camera is still attached to the entity. To stop the camera from moving, we can attach it to the default place mark. Next, let's import the airspeed gauge prefab we built in the last tutorial. As you can see, there is no UI layer present in the hierarchy. When I drag the airspeed gauge VSF file from the Windows Explorer into Tellus, the UI layer gets generated automatically. We can reposition and resize the widget as we normally would on a canvas. With the gauge and the UAS in place, we can now bind the two together. Right-click the airspeed gauge. Then, in the context menu, navigate to Insert, Objects, and click on Databinder. The Databinder object will be nested under the widget. Now, find the UAS entity in the Solution Explorer hierarchy. It should be under the foreground layer, nested under Scenes. Right-click it, then select Copy Path from the context menu. Next, select the Databinder under the Airspeed Gauge widget. In the Object Inspector, under Miscellaneous, select the Source Path field and paste the path into the text field. Then, add .controllers, open bracket, 0, close bracket. This will point our source path for the data binder to the UAS controller listing, and it will reference the first controller in that list. To do this, we need to name that property in the source property field. Entering vTrue KTS will point us to the true KTS property of the specified controller. Next, select the source value field to update the value. As you can see, there is now a value filling the field. Now the data needs to be sent to a particular property within the airspeed widget. If you recall in the airspeed gauge tutorial, the widget has a rotation control which we will use to control the needle. Similar to getting the path for the UAS, we need to get the path for the rotation control in the widget. Right-click the UI rotation control and select Copy Path from the context menu. Go back to the data binder and paste the path into the destination path property in the Object Inspector. You'll notice that the path that was pasted in is pretty long. We can shorten the path to make it more manageable by deleting everything before the last slash, then adding a ... This makes the path relative, which is useful in cases where you may have multiple gauges or rotation controllers. With a set path, we can access the property. Type in rotation to the destination property field. You'll notice that when you finish typing, the needle will adjust its rotation. We can test this out by modifying the flight path that the UAS is executing. In the Solution Explorer hierarchy, under your UAS entity, expand Controllers, Airplane Controller, Waypoints, then Geodetic Point Collection. This shows us all the waypoints that our airplane controller is executing. Select the point that the aircraft is heading towards, then modify the altitude in the Object Inspector. You will see the airspeed adjust in the gauge as the UAS climbs to match the new altitude of the point. We can have the UAS navigate to the next point in the navigation list by right-clicking the Autopilot node under the Airplane Controller and selecting the next waypoint from the context menu. Since the next point in the list should be lower in altitude, another speed adjustment will occur, which is reflected in the airspeed gauge.